Hi everyone. So in today's video we are going to discuss about causal and stable LTI system. Now, what is a causal LTI system? So, consider a system which has a input x of t and its output is y of t and the impulse is h of t and the impulse response is h of t. Then when you remember in the first video we learned about continuous time LTI system, right? In it we said this y of t can be represented as x of t convolution h of t, right? So how it will be? Y of t is equal to integral minus infinity to infinity h of 2 x of t minus 2 d2, right? Now, what is basically a causal system? So, causal system is a system which is independent of the future values of the input. In other words, we can say causal systems are the system which only depends upon the present and past values of the input. So, consider this term, that is x of t minus 2, and in this here this tau is less than 0. When tau is less than 0, you can say that our system will depend on the future value of input. Now how is this possible? Okay, now we can check that. So take tau is equal to minus 1. So you know that minus 1 is nothing but less than 0. Now you put here in this equation, that is x of t minus 2, then you put tau is equal to minus 1, you will get x of t minus 1. Now minus 1 will get as plus, right? So you will get y of t as x of t plus 1. Now put t is equal to 0. Now you can see that y of 0 is equal to x of 1 because x of 0 plus 1 is x of 1, right? Now this is present value and you can see with respect to this is a future value, right? So we understood that when 2 is less than 0, we will get a future. Our system depends on the future value. Now consider that x of t minus 2 is independent of, x of t minus 2 is a non-zero value. Then for y of t to be 0, what should be h of 2? Our h of 2 should be what? 0, right? For y of t to be 0, because as s of t minus 2 is a non-zero value, for y of t to be 0, our h of t should be 0, right? Here our h of 2 should be 0, right? For our y of t to be 0. So we can say that the condition for a system to be causal is our h of t is equal to 0 for t less than 0. Now how is this coming? So this is coming because as you know that for t less than 0, our system depends on the future values. So for the values for t less than 0, if we give the values for t less than 0 as 0, that is our h of t equal to 0 for t less than 0, we can say that our system is a causal system because it is independent of the future values, as causal systems are defined as a system which is independent of future values. So that is the criteria for a system to be causal. This is the criteria, that is h of t equal to 0 for t less than 0, and we can define causal signals as signals that is extending from or that exist from 0 to infinity. Now coming to an example, that is consider h of t is equal to u of t. Now what is u of t? U of t is a unit step signal with amplitude 1 and extending from 0 to infinity, right? So here you can see that this h of t is equal to 0 for t less than 0. What is t less than 0 part? This is the t less than 0 part, right? So this is the t less than 0 part, and you can see that for t less than 0 part, here as h of t is 0. So we can say that our system is causal because this is the criteria, h of t should be 0 for t less than 0. Now check LTI system is causal or not. So we have given a h of t which is an impulse signal that is at minus 2 with a strength 3. So as you can see that for t less than 0, our h of t is not equal to 0. So we can say that this is a non-causal system or this system is not causal. Now the next system is exponentially decaying function. Here signal. Here you can see this is exponentially decaying, and here our h of t is not equal to 0, right? So for a system to be causal, our h of t should be 0 for t less than 0. As for the t less than 0 part, this is not equal to 0. So we can say that this is a not causal system. So remember this criteria. So that should be followed for a system to be causal. Now coming to stable LTI systems. Here, consider that if our h of t is absolutely integrable, we can say the system as a stable LTI system. So in the stable LTI system, our h of t should be absolutely integrable. If that is not absolutely integrable, it means that this is an unstable system. So if you remember about the signals, you see that for the energy signals, one property is that the energy signal should be absolutely integrable, right? And for also, if you remember the impulse signal property, impulse signal is a signal which is absolutely integrable, right? So such signals are said to be absolutely integrable and they are also stable. Now, for a signal to be stable, integral minus infinity to infinity mod h of t dt should be less than infinity. So if you take the integral means if you take the integration of h of t dt, it should be less than infinity, that it should not be equal to infinity, or this value should be finite. Such systems are known as stable system. Now consider this value h of t, which is equal to e raised to minus t u of t. So if you are multiplying this with u of t, so you studied that u of t is a causal system. That means our h of t is equal to 0 for t less than 0, right? So this u of t exists for only 0 to infinity. So our integral, this integral minus infinity to infinity e raised to minus 2t u of t dt becomes e raised to 0 to infinity e raised to minus 2t dt. When you integrate this, you will get a finite value. So if you are getting a finite value, this means our system is stable. And also by looking at this signal, you can say that this is a converging signal. So it will be absolutely integrable. That means the system is a stable system. So by this criteria, that is integral minus infinity to infinity mod h of t dt, should that integral, if that integral is finite, then you can say our system is stable. So that is all about this video, and thank you so much for watching this video.